All right, let's get into it. Today, we're going to break down one of the absolute workhorse transformations in Informatica IICS, the lookup. Honestly, whether you're trying to speed up a slow job or you're prepping for a technical interview, you have got to know this stuff inside and out.
So here's what we're going to cover. First, we'll hit the basics. What is a lookup, really? Then, we'll dive into the connected lookup, talk about how to make it fly with performance tuning, and then we'll look at its quirky cousin, the unconnected lookup. Finally, we'll put them head-to-head so you know exactly when to use which.
Okay, so first things first. Before we get into all the different types and settings, we need to understand the core problem that the lookup was built to solve in the first place.
Picture this, right? You've got this fire hose of data coming in, millions of rows of sales data. And in each row, you have a product ID. Well, that ID isn't very useful on its own. What you really need is the product name, the price, the category. All of that info lives in a completely different table. So how do you get it?
And that, right there, is where the lookup transformation becomes your best friend. It is the tool for this exact job. It lets you reach out from your data flow, look up values in another source, and pull them back in to enrich your data. Simple as that.
So let's start with the one you're going to use probably 90% of the time. This is the default, the go-to, the connected lookup. And the name really gives it away. A connected lookup is physically connected right there in your mapping. Think of your data flow like a train line. The connected lookup is a station right on that main line. Data flows into it, it does its job, and the data flows right back out to the next step. It's in the thick of it.
Okay, now here's where things get interesting, and where a lot of people get tripped up. A connected lookup can be passive or active. The passive one is simple. One row comes in, one row goes out. It just adds some extra columns. But an active lookup, that's a whole different animal. When you tell it to return all matching rows, say find all the orders for one customer, it can take that one customer row and turn it into 5, 10, maybe 100 rows on the output. It can actually increase the row count in your pipeline.
Now, for maybe the most important part. A slow lookup can absolutely bring a massive data job to its knees. So let's talk about how we make these things fast.
We've all been there, right? A job is just crawling along, and you have to figure out why. Well, the lookup is one of the very first places you should check for a bottleneck. The good news is, IICS gives us some really powerful ways to speed things up.
The first two are just plain common sense. Don't make the database do more work than it has to. Instead of letting Informatica do a select star from a giant table, use the SQL override to grab only the 2 or 3 columns you actually need. And if you only care about active customers, use the source filter to add a where status equals active clause. Don't scan the whole table if you don't have to. But by far, the biggest performance weapon in your arsenal is caching. Think about it. Instead of running to the database for every single row in your pipeline, caching is like grabbing the data you need once, putting it in memory, and then looking it up from there. It's incredibly fast. And we've got 3 main flavors here. Static is your default. It builds the cache at the start of the job, and it's gone when the job ends. Dynamic cache actually updates the cache while the job is running, which is powerful, but it comes with a big performance hit. And then there's persistent cache, which is perfect for data that never ever changes, like a list of country codes. It saves the cache file so future jobs can reuse it instantly.
And I really want to pause on this for a second. Be very careful with dynamic cache. I mean, the documentation practically warns you that it's a costly element that will hamper the performance like anything. It has its uses, for sure. But before you reach for it, always ask yourself, can I solve this problem before the data gets to my lookup? If you can, stick with the much faster static cache.
Okay, so that's the whole story on connected lookups. Now let's flip the script and talk about its very different, very interesting alternative, the unconnected lookup.
So remember our train line analogy? The unconnected lookup isn't a station on the main line. It's more like a little service vehicle parked off to the side. It just sits there completely separate from the data flow until you explicitly call it from an expression transformation to go fetch something for you.
Now, this approach gives you some cool flexibility, but it comes with some serious limitations. First off, it is always passive. It can never, ever add new rows to your pipeline. Second, it can only return a single value from a single column. That's it. And third, you can forget about using dynamic cache. It's just not an option here. The setup reflects these limits too. You have to manually define the input arguments it will accept. Then you pick just one and only one field to be the return value.
And finally, you call it using the special lkp.lookup name syntax from inside an expression to pass it the arguments and get that single value back.
All right, time for the head-to-head comparison. This is the moment that separates the pros from the rookies. And trust me, this is a question that comes up in interviews all the time. So let's make it crystal clear.
Let's just run down the list. Linkage? Connected is in the pipeline. Unconnected is called from an expression. Return values. Connected can give you back a whole bunch of columns. Unconnected gives you exactly one. Match policy? Connected can be active or passive. Unconnected is passive only. And for caching, well, the big difference is that you lose the option for dynamic cache with an unconnected lookup.
So, looking at that chart, the big question just jumps right out, doesn't it? With all those limitations, it can only return one column. It's always passive. Why on earth would you ever choose an unconnected lookup?
And the answer is in one beautiful word: reusability. Let's say you have complex logic like if a flag is Y, look up a value in table A, but else look up a different value in table B. Instead of dragging two different connected lookups onto your canvas and cluttering everything up, you can build one unconnected lookup and just call it multiple times with different arguments inside a single expression. It's clean, it's efficient, and it's elegant.
So, at the end of the day, the choice really comes down to your strategy. The connected lookup is your heavy lifter, your workhorse for enriching millions of rows with lots of data. But the unconnected lookup, that's your surgical tool. It's for smart, reusable, conditional logic. So the next time you open up a mapping, take a second and think, do I need a sledgehammer or do I need a scalpel?